Okay, this is lesson 8.1, which is the first lesson of the unit on surface area and volume of prisms and pyramids. So today I can calculate the area of nets, which really is the surface area from nets. Okay, so what is surface area? Surface area is the composite area of all the faces in a three-dimensional solid. So really quick, composite, just a reminder, is kind of like the total sum. Right? So the composite area is like the total sum of all the faces in a three-dimensional solid. So here you have an example of a three-dimensional solid. A face is one side of the three-dimensional solid. So this is one face, right? This is a second face, and every single 2D side is a face. So you can think of this as like a side of a three-dimensional solid. Okay? Now, the lines where the segments where they intersect, like these segments here, these are what's called edges. Okay, so these are all edges. This is another edge because the edge is where two faces meet. See, there are a lot of edges in this. Okay? Each of those is an edge. Okay? Now, just so you know, no, we're going to talk about that next. Sorry. So surface area is the area of all of these. We'll add up the area of this, plus this, plus this, plus this, plus this, and that will give us the total surface area. Okay, now what is a prism? A prism is a 3D object with parallel congruent bases. Okay, so right now we're going to draw what's called a triangular prism, and I'm going to draw it with you so you can see how that relates to this definition. So it's a 3D object with parallel congruent bases. So the base is always going to be the first word. This is telling us that the base of this 3D solid is a triangle. So I'm going to draw a triangle. Now, prisms have two congruent bases that are parallel, so off to the back and to the right, I'm going to draw another triangle that is congruent to this triangle. These could be parallel, but they are definitely congruent. Now, to show that this is a 3D solid, we're going to connect each of the vertices with an edge. Now you've drawn a 3D triangular prism. Again, it's a triangle because it has two congruent parallel bases. All right, so just a quick note, all prisms have rectangular lateral faces. So that's a rectangle, the other side is a rectangle, and the bottom here is a rectangle. So prisms will always have rectangular sides, and the base is whatever the title says. So a rectangular prism has what shape of a base? A rectangle. So you can draw a rectangle, then you draw another rectangle, and when you get good at this, you'll know which segments you need to draw with dotted lines, and then you connect all of the vertices. This is a rectangular prism because it has two congruent parallel rectangle faces. Okay, then we have a pyramid. A pyramid is a 3D solid with a polygon base and triangle sides. In other words, the lateral faces are triangles. that meet at an apex. So let's go ahead and draw a rectangular pyramid. Again, the difference between a pyramid and a prism is it has a polygon base. So the single polygon base is going to be a rectangle. So we're going to draw a rectangle. I'm going to draw this a little bit differently. I'll draw a rectangle like that. And triangle faces that meet at an apex. So an apex is like a single point where all of the lateral edges meet at. This is the apex. So this one looks a little bit weird, but this is a rectangular pyramid because the base is a rectangle, and they all meet at a single apex. So let's draw one that makes a little bit more sense. This time, draw your base like a parallelogram that shows a little bit more of like a 3D space, but it's still a rectangle. And then go ahead and put a point above it. That point will be the apex. And then connect each of the lateral edges to the apex. This might look like a little bit more like a triangle, like a rectangular pyramid. Okay, so these are all the vocabulary words: surface area, prism, pyramid. And today what you're doing is you're finding surface area from nets. So I'm going to go back to the launch really quickly to kind of talk about that. So in your practice today, this is a three-dimensional solid, right? This is a rectangular prism because it has a rectangle base, okay? And this is a net of the rectangular prism. So if I were to like cut this out, imagine this is a cardboard box and I were to cut it apart, it would look something like this, okay? These edges, 5 and 5, you can see right here and right here. So these are like, these back flaps were cut and then laid flat down. Then, say for example, this face here is this one here. And then all the other ones that wrap around it. Okay, so anyways, a net is the like cut apart version of a 3D solid. So the way that you're going to find surface area today is by finding composite area, right? So what we'll do is we'll find the area of this rectangle and add it to the area of this one, this one, this one, this one, and this one, right? So the surface area will be the area of that rectangle, which is 9 by 5, plus the area of this rectangle, which is, if that's 9, this is 9 by 5 again, plus the area of this rectangle, if that's 9, this is 9, plus the area of that rectangle, if this is 9, this is 9 by 5 again, plus the area of these two squares that are 5 by 5. So notice that I use like pictures to show. Now, this is a rectangle, so it'll be base times height. This is a rectangle, so it'll be base times height. Rectangle, base times height. And I hope you get the idea, right? So you'll do all of that, you'll add them together, and you'll get the total surface area. For this one, I want to talk about it really quickly. We'll find surface area the same way. We're going to find surface area by finding the composite area. This is actually a square pyramid. And the reason it's a square pyramid is because the base is a square, and then it has triangle lateral faces that meet at an apex, and that's why it's a pyramid. So for this one, we're going to find the area of the square, which is 5 by 5. Then we're going to find the area of these triangles. Notice that they're all congruent. 5 by 6, 5 by 6, 5 by 6, 5 by 6. So there are 4 of them. And again, it's 5 by 6. So we find the area of this by doing base times height. And then we find the area of the triangle by doing base times height divided by 2. So just remember, depending on what shape this is what formula you're going to use. This will give you the surface area of the three-dimensional solid from a net. Definitely use the answer key to help you get started on your practice.